Okay, first video in paper 1 2018. Remember, what you need is your paper to work through. Maybe you've already done the questions and you're checking through, or you're working through to learn as you go. This is the first question Pedro and I are going to take you through, and the first part is that sonar, or we're told that sonar is an example of ultrasound, and we are going to get 1 mark for stating one other example of ultrasound. Just a very brief recap reminder: humans and Pedro's people from Andromeda coincidentally can hear frequencies of sound between 20 and 20,000 hertz. So if it's above 20,000 hertz, we call it ultrasound, and if it's below 20 hertz, we call it infrasound. Think about your ultraviolet and infrared when we're talking about the EM spectrum. So anyway, this is just a knowledge recall. You have to know some other examples. The obvious one with a bit of a funny spelling I would go for is fetal scanning. So scanning, obviously, a fetus in the womb. But, you know, it's GCSE. You'll be able to get away with baby scanner, pregnancy scanner, something like that. But ideally, I want you to be writing fetal scanner. Other sorts of animal communication. In class, I show, you know, the device to make an annoying sound for teenagers. They use those for cats as well. So there's lots of different things, but I'm going to say go for fetal scanning. Okay, and part B is also a 1 mark question. State an example of a use of infrasound. And again, there are a number of answers, but the one I want you to focus on is studying. So just be clear, that was our answer to ultrasound. This is our answer to infrasound. I want you to learn this one because it's going to come up potentially in different questions on other papers, but studying the Earth's structure. Studying the Earth's structure, and I'm sure there are papers where that comes up in much more depth than 1 mark, so we'll go for that. All right, we've then got a calculation next. This is a really short question to kick us off. We've got 4 marks here, and then 6 marks is the total of question 1. So 4 marks for this tricky question here. So we've got a graph, and immediately it kind of messes with our understanding of graphs. Normally we're used to and kind of being the other way around, right? But here we've got distance from the shore along the top, and on the vertical we've got the depth of the sea. And it shows us using sonar the different distances or the different depths of the sea from distances to the shore. So it's kind of mapping out the sea floor. I've just put in the important numbers here just so we can get straight to the point, but obviously you will need to carefully read those off. So what the technician measures or uses sonar pulses to measure the depth when the boat is 120 meters from the shore. So at this point here, and we need to calculate the total time for the sonar pulse used to make this measurement. So essentially we've got to read off here, and we've got to see that the depth of the ocean at this level is 14 meters. Now, as always with equations or a calculation, let's write down what we've got. So we've got distance from the shore is 120. But actually what we're doing with that is we're using that to work out the distance of the bottom of the ocean. So our actual distance that we're measuring is this value here. So we could be thrown by there because you've got 2 distances. We're using that first one to read off this point here. Now, if we know about sonar, we know that the signal has got to go down and then back up again, right? So what we're going to have to do to the 14, we're going to multiply it by 2. So the actual distance that our signal has travelled is going to be 28 meters. That's super important. And the speed, or let's put the sonar pulse travels in seawater is 1,600 meters per second. Okay, and where we could lose the mark is not realizing that we need to multiply by that. But hopefully now we can use one of the first equations we learned. Speed equals distance over time, and what we're interested in working out is the time of travel of this pulse. So we're going to rearrange. I'm not going to go into full rearrangement in this video, but just ask if you want me to make another one on that. So we're going to rearrange, and we're going to get that time is distance over velocity. Let's put the numbers in. So 28 divided by 1,600. 28 divided by 1,600, and that gives us 0.0175. Okay, 0.0175 seconds. We will go into this later, but if we're going to leave that to two significant figures, I'd actually put 0.018, but either of those will be absolutely fine. And that's the end of video 1, short and sweet. If you want more, click like, and I'll know that you are wanting to carry on going through the paper, and I will happily make some more. Otherwise, until then, see ya.